Okay, so today we're going to be doing our 3.5 notes, which is actually algebra review. Yes, you should have gotten to this part of algebra last year when you guys took Algebra 1. So our goal for today is to write linear equations in the form of y equals mx plus b and to graph them. So slope-intercept form is y equals mx plus b. A lot of times most of you guys will remember this from last year, so we might just be touching up on these things. M is going to stand for the slope. B is going to be 0 comma b would be your y-intercept. Okay, so that's a point on the graph that the line is going to, the graph will go through. To find slope, that equation is the m. Okay, so that's the slope. It's rise over run. Some people like to spell rise with a y because then it helps them remember that the y's are on top, because the formula for it is y2 minus y1 over x2 minus x1. So the first thing that we're going to do today is we're going to find the slope of a line containing 2 points. So the slope of the line that goes through the points -1, 7, and 4, -5. What we would do here is first start off by writing out our formula. So our formula is y2 minus y1 over x2 minus x1. And then what you're going to want to do is you have to actually pick a point 1. If this is the first one is point 1, we would call this x1, y1. This is an x, this is a y. They're in alphabetical order. So we'll label this x1, y1, x2, y2. And then all we have to do is fill in the numbers that we know. So this will be y2 is -5 minus y1 is 7 over x2 is 4 minus x1 is -1. Now the reason why I put those in parentheses is because a lot of people will not put them in parentheses and they won't put the double negative there. That's really important because 4 minus -1 actually turns into 4 plus 1. So this would be 4 plus 1 on the bottom, and we still have -5 minus 7 on the top. -5 minus 7 is -12 over 5. Now, in some scenarios, what we will actually have to do here is we'll have to reduce the fraction. We always leave it in a fraction form, and you'd have to reduce it. But you don't want to change it to a decimal, because more than likely, if you write it as a decimal, you will then round, and when you round, it is no longer accurate information. So you're going to always leave it as a fraction and just reduce. So the next one, what we're looking at is our rise over our run. So when we look at the rise, it doesn't matter if you go from this being 0.1 or this being 0.1. So I like to start with the one on the left because I always like to read it like a book. So if I'm reading it like a book, it's going to go down. That tells me overall my slope is going to be a negative slope if you're going down. If you're going to the right and up, those would be positive slopes. So that'll kind of help you identify if your rise over run ends up being correct. So when you move down on the graph, that is actually negative. So this went down 1, 2, 3, 4. So it went down 4, so that's -4. And our run goes to the right. Right is positive on a graph, so this goes to the right 6. So our rise is -4 over our run was 6. And then what we have to do is we actually have to reduce this fraction. So when we reduce it, both the top and the bottom are divisible by 2. So when you divide the top by 2, you get 2. You divide the bottom by 2, you get 3. So your slope is -2/3 there. So being able to identify the movement. So if your slope is, so the movement is the direction that you're moving from point to point, and you can tell the direction from the slope. So our rise here is 2, which tells us that we're going to go up 2. And the run tells us is a positive, so we're going to go to the right 3. So we move up 2 to the right 3. Go ahead and pause the video, and I want you to try and figure out the other 3. Okay, so let's take a look at these. For the second one, it was a negative divided by a negative, which is actually the same thing as if we were to write 2 over 3, because a negative divided by a negative is positive. So we could have said this went down to left 3, or if you're going down and to the left, so this direction, that's the same thing as if you were to go up and to the right, so going in this direction. So your line, when you connect it, will still be the same line if you go down and to the left or up and to the right. It's still going to create a line that looks like this. Okay. For this next one, there's only one negative sign, so it is negative, meaning it's going to be going down and to the right when you read it like a book. Okay. So you can go down 1, right 2, or you can go up 1, left 2. But either way, you're going in this direction. So it doesn't matter if you move the negative to the top or the bottom when you have one negative sign. This one was just 4, but 4 is the same thing as 4 divided by 1. It doesn't change the value if we divide by 1. So you can say, if you want to write it like that, that way you can see the bottom number, the run, you're going up 4, right 1. So in order to find the beginning, so you have 2 big ideas here. You have to be able to identify the movement, and you have to identify the beginning when you're going to graph this. So the beginning is going to be the starting point. Okay, which is actually going to be your y-intercept. Okay, so when graphing a linear equation, you have to use the starting point and then the slope, the directions. And the starting point is going to be your y-intercept. So here, what we want to start with is we want to identify the directions and we want to identify the starting point. So the directions here, our slope is negative 2/3. That tells you this is going down 2, right 3. And the starting point is the b, which is negative 2, okay, because it's plus b. So when you minus 2, that's negative 2. So our starting point is at 0, negative 2. It's 0, b, okay? So our starting point, that point, you don't move to the left or right at all, but you go down 2, and you're at that point right there. Then when you use the directions, you're going down 2, right 3, down 2, right 3. Then when we run out of space that direction, we're going to go in the opposite direction. So up 2, left 3, up 2, left 3. And then what we can do is we connect all the points with a line. So we connected all the points with a line, and we should probably put some arrows on the end of that line because it does continue forever in both of those directions. But there is the line for the equation y equals negative 2/3 x minus 2. Notice that the slope is going down as it goes to the right because it was a negative slope, and it's hitting the y-axis at that negative 2 mark because of that minus 2. The next one says to graph a linear equation that has a slope of 1/2 and goes to the point 1, negative 4. Then write the equation of the line. So if I need to graph this, what I'm going to do first, this time it tells me the starting point. The starting point's at 1, negative 4. So I'm going to plot 1, negative 4, which is right 1, down 4. Then I can use my directions, which is my slope, which is 1/2, that says rise 1, run 2. So up 1, right 2. So I'm going to add more points to my graph until I've run out of space. And then I can go ahead and connect that with a line. So now that I have that line, I can look and I can say, okay, now there's 2 ways that you can go about this. But I'm going to show you the first way here. So I know that I'm trying to write the equation y equals mx plus b. And I know the m. I know that the m is 1/2 x. But I'm stuck because I don't have b. So what I'm going to do is I'm going to fill in the x and the y that I know and figure out what b would be necessary to make that equation true. So the x that I know is 1. So I'm going to fill in. The y will be here, 1/2. My x is going to go here, plus b. The x that I know is 1, so I'm replacing x with 1. I'm going to replace y with -4. And then what I'm going to do is I'm going to figure out what b would make this equation true. So -4 equals 1/2 times 1 is 1/2 plus b. Now, I'm going to have to subtract 1/2 on both sides to get b alone. And I'm going to get -4.5 is equal to b. And you can see that here in your equation, that it's in between -4 and -5. You can see that it's -4.5. Now, you could write it as y equals 1/2 x minus 4.5. Or, if you would like, you can write 4.5 as a mixed number. And you can write y equals 1/2 x, that would be 9/2, so minus 9/2. Usually in math we will use mixed numbers improper fractions, such as this, over a mixed number, because this is kind of tricky to type in your calculator. Most of you know that's -4.5, so you'd be able to type that in your calculator, but if this was not a fraction that's easily converted to a decimal, it gets really finicky typing that into your calculator. So a lot of people, when we're dealing with math, we will keep things as improper fractions. So this might be a little bit easier. Convert from standard form to slope-intercept form. So what is standard form? Standard form looks like this. ax plus by equals c. So an example, you might see something like 3x minus 4y equals 12. The a, the b, the c are all going to be numbers, okay? But they're not going to be fractions because they're going to be integers. We'll get into that more details in Algebra 2, but I just want you to recognize that the x and the y are both going to be on the left side of the equal sign, and the number will be on the right side of the equal sign. And slope-intercept form that we're going to try to convert to is y equals mx plus b. So we're going to have to try and get y alone. So we're going to have to get this term by itself and then divide everything by b. So this is an example of slope-intercept form. And so as I mentioned, the first thing that you're going to do is you want to get that y term by itself. 4x minus 4x is 0x, so that term goes away. On the left side, we're left with -5y equals, on the right side, 20 and -4x are not like terms. So we're forced to write this -4x plus 20. Now y is still not alone. It almost looks like y equals mx plus b, but the y is not alone. So we're going to have to then go and divide everything by -5 to get y by itself. So we have y equals, a negative divided by a negative is going to be a positive. So 4/5 x minus, because positive divided by a negative is a negative, minus 4. 20 divided by 5 is 4. So that would be your answer here. Y equals 4/5 x minus 4. That's how we would convert the standard form into slope-intercept form. The last form that we are going to talk about today is point-slope form. This is the one that's most often forgotten about. But y minus y1 equals m times x minus x1. And what it is x1 comma y1 can be any point on the line. And then m is still going to be your slope. So this first example, it says, given the point -3, -2, and a slope of -4, write the equation in point-slope form. Remember, point-slope form is y minus y1 equals m times x minus x1. When you go to do the assignment, if it tells you your answer should be in a specific form, I would write it like at the top. I'd write the forms at the top of your paper so that way they're nice and easy to just look at, okay? Then when you go and you know that your answer is supposed to be in point-slope form, double check that it's in point-slope form. When your answer is supposed to be in slope-intercept form, you can double check and make sure your answer is in slope-intercept form. So we are going to write an equation in point-slope form, and then we're going to convert that to slope-intercept form, which is y equals mx plus b. Okay. So when we go to write this equation, here is your point. That's any point. It's not a special point. It's not an intercept because we're going to go to the left and down. So you're not on an axis anymore. Okay. You're also going to have a slope of -4. So we're going to fill that into our point slope form equation. This one here. So every equation has to have a y. Every equation has to have an x, and that's where they're located. And we're going to fill in the rest. So we have y minus x minus, okay, then we have our point. So y minus the y of our point is -2. The x of our point is -3. And the m, that slope, is -4, which goes right here. So then what we have to do is, there's only one other step, and it's just that we don't like to write things with minus a negative. We're going to write that instead as y plus 2 equals -4 times x plus 3. That's done. That is point slope form. Okay, there's nothing else to do. Some people try to start moving things around, distributing. We're not going to do that yet. That is point slope form. So if we're asking for point slope form, that's what it's going to look like. Now when we convert it to slope intercept form, now we have to get y alone. We also are not allowed to have parentheses. So we're going to take that 4 and distribute. When we do that, we get y equals -4x minus 12. And then we're going to have to subtract 2 on both sides. Notice I subtracted 2 with the like term. I lined it up with the like term. That would make the 2's go away on the left. And we're left with y equals -4x minus 14. And that would be your final answer.